Okay, so for today, we're going to have to talk about some special triangles in order to find the coordinate points on a unit circle. So we just have a tiny bit more to talk about the unit circle, but there's kind of some things we have to go over beforehand. With special triangles, you would have learned these in geometry. There's two specific ones. One is a 45, 45, 90, and again, I'm referring to angles. In that triangle, those side measures is 1, 1, root 2. With root 2 being the hypotenuse. Then we have a 30, 60, 90. So this is both 30, 60, 90 triangles. There's just both written in like two different kinds of forms, right? One with 30 degrees on the bottom and one with 60 degrees on the bottom. So they can just kind of be flipped around a little bit. When we're dealing with that kind of triangle, you're going to have sides 1 to root 3, with 2 being the hypotenuse, 1 being across from the 30-degree angle, or the smallest angle, smallest side, root 3 middle side across from 60, the middle angle. Okay, so I made you kind of a tiny little table here, just so you would kind of know. It's the 30 across from 1, 60 across from root 3, 90 is across from 2. But those are our two special triangles that we're going to deal with today. So when we write these coordinate points, we write them as x is referring to cosine and y is referring to the sine value at that particular part on the unit circle. So the way I remember these best is when we're talking about like x, y, it goes x, y, z. So x and y are in alphabetical order, so are cosine and sine. Z comes before S in the alphabet, so it goes alphabetically. I also want to remind you that when we're talking about a typical graph, like XY plane graph, it goes quadrant 1, quadrant 2, 3, 4. So you count counterclockwise. And in quadrant 1, both x and y are positive. Quadrant 2, x is negative, y is positive. Quadrant 3, both are negative. In quadrant 4, x is positive, but y is negative. Okay, those will be important to know. And if you haven't already thought we were on the way headed towards SOHCAHTOA, we are there. So if SOHCAHTOA is what works best for you, that's fine. I have like a little saying I want to show you. If you set it up as SCT, right, sine, cosine, tangent, there's a little saying that can kind of work your way through it. So it starts with O. So if you go through the whole saying, it's Oscar has a hairy old armpit. And you can fill in the entire thing just with the first letter of those. So Oscar O, Harry H, A. Oh, sorry, no, that's Oscar has. So O, Oscar, has H. A is just A. Harry H, old O, armpit A, right? So Oscar has a hairy old armpit. That's how I remember it. You can remember it SOHCAHTOA. It doesn't matter. Whichever way works for you. So I'm going to flip over to a clean unit circle here. And essentially, quadrant 1 is the one that I really need to focus on with you. So if you can't see the rest of them, it's okay. I have it all the way all labeled out already. So two things I've added in or 4 things I've added in so far is these coordinate points. So if you look at over here, I labeled this 1, 0. And again, this is for sine or cosine, theta, sine. Okay? So when you're thinking about this on a coordinate plane, we go over 1, up none. So this point is 1, 0. Again, cosine, sine. This point up here is 0, 1. We went over 0, up 1. Over here, we have negative 1, 0. And down here, 0, negative 1. So we can label all those points with whole numbers. Okay? The rest of them are going to be kind of nasty fractions. So I want us to first focus on this pi over 4 in quadrant 1. This is 45 degrees. So that's saying from here to here is 45 degrees. So think about the triangle we're making from right here to here to here, okay? Kind of fill that in from right there to there to there. You have a 45, 90, so it must be 45, 45, 90, because if this is 45 degrees, this is 90, this also has to be 45. So think back to our special triangle. When we had a 45, 45, 90, the sides were 1, 1, root 2. Okay? Again, I'm getting this from down here on the triangle. This is a 45, 45, 90. We want to know what is my sine and cosine values. Cosine first, then sine values out here for this pi over 4. In order to find those, we have to use SOHCAHTOA, right? If this is 1, 1, root 2. Yeah, I wrote it the right way. Okay, I just wanted to make sure. So thinking about this as SOHCAHTOA, okay, again, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Okay, so our theta is right down here in the corner. So our theta for this triangle will also be right down here in this corner. That's where we're going off of, okay? So the way I like to say it is you're like a little person standing in this corner, and you want to say, first, for cosine, what's adjacent to me? So that's the kind of thing that you could like walk across to. So that's going to be 1, again, for cosine. 1 over hypotenuse, root 2. For sine, we're going to be taking opposite. So opposite's the thing I'm looking across. So that's also going to be 1 over hypotenuse, which is root 2. So we're getting for both of these 1 over the square root of 2. If you know anything about roots, you know that we don't like to have them in our denominator. So you're going to have to rationalize the denominator. This is something you would have learned multiple times before in the classes before this. But essentially, that's multiplying by a funny looking 1. You take the denominator over the denominator and multiply it straight across by it. So we will get root 2 over root 4, or root 2 over 2, because the square root of 4 is just 2. If we simplified sine the exact same way, we would still get root 2 over 2. So I don't need you to show me both of those. All right, so let's come down here to our unit circle. We said that cosine was root 2 over 2, and sine was root 2 over 2. So we know quadrant 1, both of those are positive. What I've currently written for pi over 4, these coordinates don't change for any of the other pi's over 4s. Pi over 4 and pi over 4. The only thing that changes is my negatives, okay? So let's go write this in 3 pi over 4. It's root 2 over 2, root 2 over 2. But think about quadrant 2 has x values that are negative. So I have to make this a negative root 2 over 2, root 2 over 2. Down here, 5 pi over 4, both are negative. So it's negative root 2 over 2, negative root 2 over 2. And quadrant 4, x values are positive, y values are negative. All right, let's move on to another triangle. So let's go to this 30 degree. 30 is this first one, right? If I go here and drop a triangle down, this is a that's a 90 degree angle. I'm focusing on this one right here. That's a 90 degree. And this small little portion is a 30 degree. That means that out here must be 60. Okay, so I'm working with a triangle with 30 degrees in the bottom. So let me move this up. This special triangle, 30, 60, 90. Again, 30 was down here, 60 up top, 90 in the corner. So what we know about 30, 60, 90 is that 2 is my hypotenuse going across from my 90. Across from my smallest angle will be 1. Across from my middle angle is root 3. Okay, so again, we need to do sine, which is opposite over hypotenuse, and cosine, which is adjacent over hypotenuse. So let's do cosine first, as that comes first. So for cosine, I'm looking down here. Again, I'm the little guy in this corner. Adjacent to me is root 3. And hypotenuse is 2. Now opposite me is 1. Hypotenuse to me is 2. So this is the coordinate point. Root 3 over 2, 1/2, right? Because cosine comes first. So at my pi's over 6, it's going to be root 3 over 2, comma, 1/2. Okay, so go fill that out for the pi's over 6's, except add the according negatives. And last one over here. All right, last triangle then is this, oh, let me go back up here. This very, very last one, right? That's my 90 degrees. Pi over 3 gives me 60. So my big corner angle is the 60 degree. Okay, so I'm going to flip this over for a second. This is the kind of triangle that that's giving me. 60 in the corner. So if we're trying to make a cosine sine, again, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse. So cosine first. We're the little guy standing in this corner. Adjacent to me is 1. Hypotenuse is 2. Sine, opposite me is root 3. Or hypotenuse is 2. This is creating the coordinate point, 1/2 root 3 over 2. So at our pi's over 3, that's what we put, 1/2 root 3 over 2. And again, negative 1/2 root 3 over 2. Negative 1/2, negative root 3 over 2. And positive 1/2, negative root 3 over 2. All right. So when you're getting this done, you should have coordinate points at every single line that we've marked off here, right? Coordinate points at every single line that we've marked off. So I will give you like a nice, clean, printed out version of this to kind of keep and have. But the important part is that you're able to make this on your own. Again, you're not going to be able to use a unit circle on any exam. So you have to be able to build this, understand the unit circle, and make it on your own. Okay, that is it for the unit circle.